This is part 2 of section 2.6. We just talked about combinations of functions. Now we're going to talk about composite functions. Basically, what a composite function is you're going to take a value, you're going to plug it into, say, g. You're going to find that answer and then plug it into f. That's what this one says. You find g of x, you take your x, you plug it into g. You get that answer and you plug it into f. This one says you take f, you take x, plug it into f, take that answer and plug it into g. This is read basically f of g of x, or f composed with g. That's what this one is read as, this part right here. Okay? Please don't read it as fog and goth. That really annoys a lot of people, myself included. Okay. Now what we're going to do here is we're going to find each of the above. We're going to find f of g of x, and we're going to find g of f of x, and often they are different. And then we're going to talk about the domain. Okay? So when we go to find the domain, we have to worry about what makes this one bad, whatever's inside here, and whatever makes the whole thing bad. It's not going to be each piece individually this time necessarily. We have to worry about the domain of the inside part, and we have to worry about the domain of the whole thing. Okay? So if I just look at these two right here, just look at them individually. F of x equals 2x. There's no denominator here. There's no radical here. The domain here is all real numbers. The same thing here. So individually, f of x does not have any issues. G of x does not have any issues. Okay. So let's find f composed with g of x. And I'm going to write out every single step here. Okay. By definition, this is f of g of x. So what I'm going to do is I'm going to take, I know what g of x is, it's all of this. So I'm going to replace this with this. So this is f of x plus 7. Now, if I had an issue with my domain in here, it would be part of the issue with the domain for the entire problem. But this doesn't add any issues here, so I get to keep going. Now what this says is where the x is in f, I'm going to plug in x plus 7. So this is the same thing as 2 times x, but instead of x, it's x plus 7. Now let's simplify this by distributing the 2, and you got 2x plus 14. So I look here, x plus 7, and I have no issues. And then I look here, 2x plus 14. I have no issues here either. So the domain for this one is all real numbers. Okay. Now let's try this one. For g composed with f. So this is g of f of x. Sometimes these are the same, but most of the time they are different. When they are the same, we have some special cases, and we'll be talking about those later. So this is g of f of x. So I'm going to find my f of x, which is right here, and plug it in. So that gives me g of 2x. And when I'm looking for domain, I'm going to see if I have any issues with 2x, because that's the part I'm plugging in, and there are no issues there. So now I take the 2x and I plug it in for x here. So that's 2x plus 7. They're kind of similar, but this one did not require a distribution, and this one did. So you can see that the two things are different. And now I look here to see if there are any new issues, and there are not. So this domain is also all real numbers. Okay, so let's try this one. F of x is 2 over x plus 3, and my g of x is 1 over x. Okay, so let's look at each of these. Each of these has their own little issue. For f of x, I have a denominator, And I'm worried about when x plus 3 equals 0. Well, when does that happen? When x is negative 3. So if I'm plugging in f of x anywhere, I'm not going to be allowed to use 3. For g of x, this denominator is 0 when x is 0. So if I'm using this one by itself, I'm not going to be allowed to use x equals 0. Okay, so let's find f of g of x. So this is f of g of x. I know my g of x is 1 over x, so this is f of 1 over x. Now, since I'm using 1 over x here, it doesn't matter what I get after I do all of my simplifications, after I plug this in. I already know that my x is never going to be allowed to be 0. Even if all of the apparent problems disappear, I'm not going to be allowed to equal 0. Okay. So now, let's take this and we're going to plug it in here. So this is 2 over 1 over x plus 3. Okay, now I can simplify this if I want to multiply the top by x and the entire bottom by x. That will make this fraction go away, and I get 2x is equal to, that's going to be 1 plus 3x. So if you're just asked to find f of g of x, this is your answer. Now we were asked to find the domain as well. And I look at the part I plug in, which I have a problem at 0, and then I have to look at my overall answer as well. So this means that since I have 1 plus 3x in the denominator, I need to figure out where this equals 0 because that's not going to be part of my domain either. So this is 3x equals negative 1, x is equal to negative 1/3. So for this f of g of x, my domain cannot include 0 and it cannot include negative 1/3. So this domain is a little bit uglier. I start at negative infinity and then I go up to negative 1/3 is smaller. Ignore that, it should be a comma. Negative 1/3 union, and then I can go from negative 1/3, remember these are parentheses because we're not allowed to equal them, up to 0. And then you cut out the 0 and you go up to infinity. So I cut out the negative 3 and I cut out the 0. So this, all these three pieces, that's the domain to f composed with g. Okay. Now let's go the other way. G of f of x. Okay. So this is g of f of x. So I take and plug this whole thing in right here. So this is g of 2 over x plus 3. And again, I worry about what's inside. And right here, I know that x cannot equal 3. So x is not going to be able to equal 3 for any of it. Okay, I know that has to be taken out at minimum. Okay, now let's see what we get. Well, this is 1 over x. That's just telling you to take the reciprocal of it, right? It means just flip it upside down. So this is the same thing as x plus 3 over 2. Okay. Now I look at this answer. Is there anything that can give me a problem? Well, I don't have any variables in the bottom here, so there's nothing that can give me a problem whatsoever, except for this 3, which I was not allowed to plug in here. So this domain, all I have to do is I have to cut out the positive 3. So this domain is from negative infinity to positive 3. Cut that out and go from 3 to infinity. Remember, you only look at the part that you plug in and then your overall answer. I did not have a problem with 3 in this first one because I never used this one directly. I don't have a problem with 0 here because I never used 1 over x directly. I was plugging something else in.